नमस्कार, आप सभी का बहुत बहुत स्वागत स्टूडेंट्स. Today we are going to learn a very important technique of algebra known as partial fractions. This technique is very useful to solve complex series problems and to solve difficult integration problems. I hope this technique will help you a lot in competition exam. Let us learn how this technique works. I am starting with a very simple fraction here. I am taking 1 by 2. So this denominator part I can write as 1 into 2, and now here you see these two number 1 and 2, the numerator is the difference of the denominator two factors. Okay, so you can easily split this as 1 upon 1 minus 1 by 2. You can verify also by taking the LCM, this equal to 1 by 2. Similarly, you can take now 1 by 6, say split or factorize the denominator into two parts. Here the two parts are 2 and 3. Now you can very easily write 1 by 2 minus 1 by 3. And in the same way, suppose I am writing 1 by 20, 4 into 5, you can write like this. So there is a simple fraction here, and that simple fraction is partially splitted into two fractions. So this simple fraction is splitted into two partial fractions. Now how this technique will help you to solve series problem, that also we will cover. But first you see here how this splitting is done. Now the next, let us generalize this. If suppose I write x square plus x, so this is x into x plus 1. I am taking x as common. So here are two factors. Now you can very easily write. Okay, you can take the LCM and verify the result whether we have done it correctly or not. Now we will take some examples how this technique, where we are splitting a fraction into two fractions, one part is positive and other part is negative, will help you to solve a long series where we are asked to add some terms. Okay, number of terms, say 20 terms, 30 terms, or say n terms. So let us take the first example based on this technique. Here is a series. The series is given like this: 1 by 2 plus 1 by 6 plus 1 by 12, and we are asked to sum up to n terms. Now here the denominator part, if you look at those parts closely, what you will see here, that denominator we can write something like this, and similarly this 6 also we can write like this, 12 we can write. So we are factorizing. Now let us write the nth term also. And how we will write the nth term? Just look at these terms and the denominator part. In the first term here is 1, the second it is 2, the third is 3, the fourth is 4. So the nth term, the denominator, the first factor will be n. The next factor is 1 more than the preceding one. So I can write n plus 1, numerator as 1. Now what I will do further? You split each fraction into two parts so that the fraction will cancel each other, because many terms, whenever we are need to add them, if suppose these terms cancel each other, that cancellation effect, if it takes place, it will make our question very easy, because finally we are left with few terms which we can very easily plus or minus, we can add them or subtract. So here this is 1 by 1 minus 1 by 2. Now the second fraction also partially we split into two parts. One part is positive and one part is negative. Why we are bringing the negative part? Because it will cancel the next part of the next term. So this cancellation will take place up to the final term, and it will make your question very easy. Okay, the final term I can write like this. Now look here, each term is splitted into two parts. One part is positive, another part is negative. Now the second part of each term, is cancelled by the first part of the next term, and this will take place up to the last term of the series. So this cancellation you do, In the same way, the last term, there are two parts. The first part of it will be cancelled by the preceding one, as it happened in earlier terms. So now we are left with only two fraction, which we can very easily manage and calculate it 1 by 1 and 1 upon n plus 1. Take the LCM, it will be n plus 1, here n plus 1 minus 1, and finally you will get your answer. You can verify your answer also. This is the sum of this series. So suppose if you put 1 here, you will get the sum of one term. If you put 2 here, you will get the sum of 2 terms. And if you put 3 here, you will get the sum of 3 terms. So in this way, we can add this special type of series. It is neither AP nor GP. Because students are unable to solve with the help of AP or GP summation formula, so a special approach we will take to solve such type of series problem, and here the partial fraction helps you a lot. I hope you have understood this problem. Let us take another example. So now we are taking the second example, and the second example is very similar to the previous one. You see this question. Here is the first term 1 and the second term is 1 by 3, the third term is 1 by 6. Now we will do some manipulation and the series will be same as the earlier one. How we will solve this question? Again, there is a trick here. You multiply by 2 and divide by 2. Okay, that is a very famous technique whenever we solve some questions in series. In same way, you can write here 1 by 6, 1 by 12, 1 by 20, like this. Now you see here up to n terms. Now this series, okay, this series is same as the earlier one. The same series we have got. Now here the same method will go. Now you can write like this, the same procedure inside. Okay, I hope you will do this. And up to n terms. The last term will be, here you write the last term, and the last term will be like this, okay, because the nth term was 1 upon n into n plus 1. So I hope you will solve at your own. The answer will be like this, because the earlier one what we got was n upon n plus 1. So the answer will go like this. We are taking another example and slight variation in this question. Just in the last question, what we did is multiply and dividing by the same number. Okay, the same type of technique here also. These numbers, if you see here, the difference of these two factors, if you make note of it, the difference is 2. So multiply and divide by 2 this time. Numerator I am writing as 2. Okay, so this 2 I can write, and divide by 2 as well. Now you write all numbers like this. Okay. Now can we write the nth term of it? Yes, definitely. Here 3, 5, 7, if you see, it is making AP, arithmetic progression. So just if you write the nth term goes like this: A plus n minus 1 into d. The difference is 2, so that is 2n plus 1. And now you can verify also. When you put 1 here, you get 3, you put 2 here, you get 5, you put 3 here, you get 7. So I can write now the nth term. Similarly, analogy concept, each term is having 2 as numerator, so there 2 as the numerator. The denominator part I will write 2n plus 1, and the next factor is 2 more than this. Okay, so 2n plus 3. Okay, so this is the second step. Now the partial fraction, we will use that technique. Now this is 1 by 3 minus 1 by 5. You can verify by taking the LCM. 1 by 5 minus 1 by 7, 1 by 7 minus 1 by 9, like this. And now 1 upon 2n plus 1 minus 1 upon 2n plus 3. So we have splitted each term into 2 parts, and we have introduced a minus here. So minus will help you to cancel most of the terms, okay, with some other terms. So this 1 by 5, 1 by 7, this will be cancelled like this. Okay, finally you are left with only two terms, 2n plus 3 and 1 by 2. Now you can easily take the LCM. The numerator 2n plus 3 minus 3, you will get 2n. The denominator is 3 into 2n plus 3. Okay, 1 by 2, the 2 is cancelled and you get n 2n plus 3. So this is very simple technique. Now we have solved 3 questions on this technique so far, and I hope you have understood the concept very well, and such type of questions can be done easily in exam. Now students, let us solve some of the integration problems based on this technique. Here is a integration which is a rational function. Numerator is 1 and the denominator is a polynomial of second degree. Here we first take the x as common and we factorize the denominator. Here you can see the difference of two factors is 1, which is equal to numerator. So if you write the numerator like this, x plus 1 minus x upon x into x plus 1, and now separately if you divide, the same technique you will understand. So we can write directly as well. Directly I can write here 1 by x minus 1 by x plus 1. Earlier in the video I told you this technique, how it works. Now it is very easy. The integration of both the terms we can do using the formula. Integration of 1 upon x is log x. So it is log of x, and this side is log of x plus 1, and constant of the integration. Your final answer will look like this, log a minus log b. Here is a property of log a upon b. So this is the answer. So it makes question very easy. So students, let us take the last example of today's video, and this is the same integration problem. Again, if you see here, there is a rational function and denominator is a polynomial of second degree. So you can now easily factorize the denominator. The denominator, if you split the middle term, you will get x plus 1 and x plus 3. I hope you will do the factorization job. X plus 1 and x plus 3 are two factors. Now if you see these two factors, there is a difference of 2, so you can put on the numerator, multiply by 2 and divide by 2, and now easily you can partial fraction you can make. Directly you can write 1 upon x plus 1 minus 1 upon x plus 3, because now you are smart enough to write directly. Now take the integration of both the terms. It is easy. It is log x plus 1 minus log x plus 3 plus c. Okay, put the bracket here. Just write, use the property log a minus log b, log a upon b. सो स्टूडेंट्स, ये था हमारा आज का वीडियो जिसमें हमने सीखा पार्शियल फ्रैक्शन टेक्निक को और किस तरह से ये टेक्निक हमारी प्रॉब्लम्स को इजी बनाती है. आई होप आपको ये वीडियो पसंद आया होगा. मिलते हैं नेक्स्ट वीडियो में. तब तक के लिए गुड बाय.